So good morning to the last day of this week, and welcome here at SAP. So Friday we have a change of scenery, and we come here, and it's always a great place, as you will see. It's a great opportunity, and I would also like to take this opportunity to thank SAP for hosting us here. You will have an interesting program throughout the morning and the afternoon, and then this evening we will not celebrate, but have our farewell dinner at the castle. And with this, it's my pleasure to introduce Philipp Herzig. Dr. Philipp Herzig, he's the Chief Artificial Intelligence Officer at SAP since early this year. He already welcomed us last year. We still had a slightly different role, but I think we're all excited to hear what he's telling about AI bridging academia and industry. Please, the stage is yours.
Thank you. Good morning, everyone, and it's a pleasure to be again with you here today. Last year, I also already make a little bit an intro, right, about artificial intelligence and what we're doing at SAP and how we work together with academia and some of the research questions, right, which keep us up at night. And so from that perspective, I also want to welcome you again here today in this distinguished round. Really happy from an SAP perspective to host you here. And yeah, for me, it's always a pleasure to work with, to speak in front of so many people who are so much smarter than I am, and so you tell me later if what I tell you makes sense or if it doesn't. Now, first of all, I would like to start this little opening when it comes to AI with a reality check of where we are right now with AI in the industry, and then take this as a bridge into like what are some of the open research questions and what we are doing to overcome current challenges and limitations when it comes to the widespread adoption of AI and specifically generative AI in large enterprises around the world, which is obviously, if you don't know SAP, what we are busy with, introducing AI into business processes. Think finance, right? Sales and distribution, HR, procurement, like warehouse management, like helping customers around the world with the help of AI, classical AI, but also generative AI, so people can achieve more with less, right? Increased level of productivity, better user experience with natural language and much more. But the problem really is what we see. I mean, we had a very hot summer, right, of AI last year specifically, still this year, right, with the rise of ChatGPT and the various generative models, right, that emerged ever since. The clicker is not working. Somebody go to the next slide, please. The clicker is not working. So the problem really is, when we look at the enterprise, this is a recent McKinsey study, we all thought this is going to happen overnight. Right? It's going to happen overnight. It's so powerful. Everybody, ChatGPT tapped into the imagination, right, also of the C-suite and enterprises because of their fantastic zero-shot capabilities, right? You can just write a very primitive, naive question, and it comes up with something very useful already. And it was like, oh, how hard can it be? Right? So that we introduced it overnight, and everything would change the world. And 2024 is a huge year of adoption in the enterprise. And in reality, it's not. Only 13% of companies have really adopted more than one generative AI use case already, right? So there's a lot of upside potential. And if we go to the next slide, this is the Gartner hype cycle. Probably you know this, right? So new emerging technologies, right? They go usually up to the peak of inflated expectations, so they say, right? Most of the technologies disappear there, right? They come on this slope and they accelerate, and they're like, whoosh, they disappear in oblivion. And then some technologies go to this downhill slope towards what they call the trough of disillusionment. It sounds very sad, right? That's very sad, and like, oh, we are disillusioned, we're very sad. No, it's actually a positive thing, because it means the technology is to be taken seriously, and this is usually the phase not where the researchers and the developers are all sitting in the corner crying because they're so disillusioned, but this is where the real work is happening, the hard work, before actually the technology may reach what we call on the right side the plateau of productivity, where really then the change also happens at scale. Now, if we look at some of the challenges that companies face, it just usually falls into these three categories when it comes to AI. The first is obviously, we always talk about data privacy, GDPR, right? All the data privacy preserving methods and so on, right? That we have been working on for years are more relevant than ever, right? Think of the Data Act in the European Union, of course the EU AI Act and so on. But of course also when it comes to harmonizing data, right? Companies who did their homework, bringing data together, harmonizing the data model, for example, and so on and so forth, have an easier life than those who didn't, for example. Then, of course, we still know there's so many limitations. I mean, generative AI models are fantastic, right? They're amazing technology, but they have limitations, right? They have limitations as to on which data they are trained. They're certainly not trained on any company's data, right? They're trained on public information. If you ask them questions, like in classical ones, not the newer ones, which increases their inference time for reasoning, they may hallucinate, making up facts. They sound plausible, but they are factually wrong. And many more things. So the question is like, how do you deal with these limitations? And then for companies, it's also very hard, like this plethora of models. Every week, 10, 100 new models are coming on Hugging Face and so on. It's really hard to keep track and evaluating all of them, right? Which is, for most companies, an inhibitor to do more because the complexity has just increased. And then finally, implementation at scale. It's really simple to, let's say, take a large language model, do what we call retrieval augmented generation. We pick a bunch of documents, right, from the enterprise that was never trained on. You put it in a context window, or use the vectorized formats out of an embeddings model or something like this. And it's totally easy. It's trivial. You can do this in an afternoon to build a POC with 10 documents, right, and show a demo to the CEO, and he will be, oh, wow, that will change everything. But 10 documents, really simple. Getting it right for 100 documents is already a little bit harder. Getting it right from a recall, classical information retrieval, from a recall and precision perspective with 1,000 documents is already a huge challenge. And then do this for documents all across a large enterprise that has documents in other languages, localized documents, right, and so on and so forth. It becomes a hard challenge, right? And this is why the implementation at scale is also currently not happening, because we still need to work on a lot of technologies, a lot of research questions that need to be answered in order to improve those things. So one of the things, and I just want to talk a little bit about this, is I just make this example here. This is a usual SAP application, and one of the things I want to talk about is metadata today. So when you, for example, go into our Copilot, you can ask a bunch of questions there, but it also sometimes doesn't know things. So if you, for example, ask them for a table called LIPS, this is a table that is line items for sales delivery inbound items in a company, it doesn't know that. And if I then ask what are the primary keys of this table, for example, it gives you an answer that isn't wrong. You cannot read it, but it's so high level, it's not useful, right? It's not wrong. It says something from the documentation, right? It's RAG on SAP documentation, but it's not targeted to the end. It's not a helpful answer. It's not wrong. It's not helpful. And so one of our key questions was, we have this amazing large language models, right, learned on mostly unstructured data. How can we bring this together with the structured world of SAP? Because the reality is most of the stuff in enterprise applications is stored in tables, right, described, so some metadata model and so on and so forth, but the LLM has really no clue what to do with this metadata. And this is why actually we're investing heavily. So I'll give you just an example. If you say, give me all the tables and CDS views, this is like, if you know SQL, right, like a SQL view, kind of thing, for getting all the details on contract accounts in SAP, and you just go to ChatGPT or use GPT-4o or whatsoever, right? It comes back with something that sounds plausible, but the reality is 70% is hallucinated. Yeah, 70% is hallucinated. It doesn't get the views right. 3 tables are wrong. These are not the tables in the SAP system. They are wrong. So how do you fix this, right? To bridge now this gap between the structured world, to ask an arbitrary question like, give me all my purchase orders with a certain supplier before September, something like this, right? It's not solvable out of the box with an LLM. And this is why we are heavily investing into knowledge graphs. Who knows knowledge graphs here in this round? Oh, I'm amazed. That's good when you talk to researchers. Most people in the industry don't know knowledge graphs. Why is that? Actually, knowledge graphs, as you all know, is actually a relatively old technology, right? It exists since when was the first, I think the first draft was 1999. I think the first one, the W3C, was 2004, version 1.0 resource description framework. And it's funny, there was an anecdote. I have one colleague in my team, he's a great researcher. He worked with Tim Berners-Lee at the W3C. He was in the XML standardization group in the early 2000s. But Tim Berners-Lee was intellectually already more advanced and went on with RDF and semantic web and ontologies and all these things. And they had huge fights, yeah? So the colleague on my team always said to Tim, like, you don't need this, right? XML is all you need. No, and now actually he's our top expert for ontologies and knowledge graphs, and later on also apologized with Tim that we was wrong because of powerful technology. But the problem all the years was with knowledge graphs, they are really hard to construct, right? To build up a knowledge graph, right? You had to invest a lot of time and so on. And it's like for many, many years, knowledge graphs really never, there are exceptions for sure, but there was no widespread adoption of this technology. Until very recently, because we realized that with generative AI and large language models, these knowledge graphs are super powerful, right? To both construct knowledge graphs, but also use knowledge graphs to ground large language models and give them structure and the relation of entities and so on and so forth. And we constructed one, a very large one for our ERP system, where we took all the data together. It constructed out of 450,000 tables, views, 7.3 million fields that describe the entire metadata model of SAP. It's a very, very huge graph. And so here's just a very small snippet, right, where we took metadata from a variety of sources, brought them all together to describe how the metadata model of an SAP system would look like. And at the end of the day, then you can use this knowledge graph to in conjunction, of course, with a large language model, in order then to really glue together the natural language what is stored and described as classical structured metadata in a tabular system and bridge this gap in between. And if you then do this actually, so if you take this knowledge graph, so same example, left side, right, on the left side, 70% hallucinations. Now if you prompt it with the respective information of that knowledge graph, all the information all of a sudden is correct, right? What you see is actually it's a little bit more ugly, so I usually recommend our developers to use ChatGPT to come up with better names. Because the hallucinated names are actually, from a product design perspective, in my opinion, better. But the reality is it is then much more to the point. And of course, the hallucinations stop to get the respective metadata. And of course, when you then use this metadata, of course, you have a much higher increased precision and recall than once you ask your questions on what you really want to know. And here you see this again. So this is our little internal discovery tool for this knowledge graph. And if you then use, again, the same question in Joule based off the knowledge graph, then, of course, as a result, you get much better answers. It explains you, for example, what this table is about. Or when you then say what are, again, the primary keys of that table, of course, then it will come back with the correct tables and the correct columns in this case, because it's actually a compound primary key composed out of 3 columns in that table, and then you can navigate to those, explain the meaning of these columns, and so on and so forth, which is then very helpful. And we use this then, for example, to bridge queries in natural language and generate, for example, SQL queries or OData queries and so on, that then pull the respective information out of those tables according to the question you are asking in natural language. And still, there's many patterns, right? It's very useful. You can do analytics with this. You can do AI-based predictions with this. Of course, in classical information retrieval, semantical exploration. And still, there's a lot of research also there required. We're not at the end, right? So that is already a big step also for us forward with such technologies. But there's still also, from a research perspective, many things. And I just wanted, in particular, because so many people obviously know of this and maybe also do some research, I can only encourage you to continue that research, because there's a lot of utility meanwhile. So I think really knowledge graphs have like a late advent after 20 years to become really, really useful also and have much, much more impact than they had maybe in the last 20 years. And with this was just a glimpse of what we're doing. And thank you so much again for joining us here in Waldorf with SAP, and I wish you a fantastic event. Thank you so much.